The air is clean. The waters are pure. Given time and space, nature has ways of cleansing itself of man's toxic pollutants. But we cannot all escape from the cities and spend our time in the pristine mountains. In the cities, we rely on transportation and heavy energy consumption. When fossil fuels are burned, they produce power and heat and pollution. Much of this pollution goes into the air we breathe. Sometimes we see ugly brown clouds where white clouds once prevailed. Sometimes our eyes burn. Sometimes the air makes people ill. Sometimes it makes them die prematurely. But man is innovative. He not only creates problems, he solves them. The winds of change are blowing. Air pollution in our cities is a solvable problem. At the foot of the Rocky Mountains, one company has dedicated itself to the problems of reducing air pollution. SuperFlow Corporation is located in Colorado Springs, Colorado, at an elevation of 6,000 feet. Here, the air density is only 80% of that at sea level. When there is less air to breathe, air quality seems even more important. For more than 20 years, SuperFlow engineers have been developing advanced engine and vehicle testing solutions. Engine dynamometers are used for measuring engine power, fuel consumption, and for developing better emissions controls. SuperFlow was one of the first companies to develop a completely integrated approach to dynamometer testing by providing all the equipment necessary to set up a test cell. Thousands of SuperFlow dynamometer test cells are now used in engineering laboratories, schools, racing activities, and maintenance facilities around the world. SuperFlow bus and truck dynamometers are used in repair centers throughout the world. Advanced automated testing programs measure power, fuel consumption, and opacity, and then compare the results to factory standards. A 9-page test report is generated, which compensates for all atmospheric conditions, accessories, and tire design used on the truck. Portable dynamometers are used to measure the power of rebuilt engines. SuperFlow towing dynamometers are used to simulate hills for engineers developing vehicle thermal control systems. The U.S. government selected SuperFlow to build all of the engine and generator test systems for its most advanced rebuild center in Tooele, Utah. 34 test cells were designed to test up to 20,000 engines a year, using fully automated test systems with branching decisions at each test point. The latest SuperFlow technology involves multiple PC computers with live video for screen capture of test setups and online live instructions. Windows-based software developed by SuperFlow provides user-designed screens for a wide variety of customized testing requirements. Another challenge tackled by SuperFlow was designing an emissions test system for Mexico City. Mexico City was very late in requiring pollution controls on the 2.5 million vehicles used there. As a result, the air became the most polluted of any city in the world. In 1992, Mexico City was frequently reaching pollution levels that were 10 times greater than cities in the U.S. Visibility was sometimes reduced to as little as 500 feet due to emissions. SuperFlow responded with a test system that was more advanced than any installed in the world at that time. The first systems went online in January 1993. SuperFlow equipped microcenters process 15 vehicles per hour in each of 6 lanes. During 1993 and 1994, up to 10,000 vehicles per day were processed. The SuperFlow test system proved to have very high reliability while maintaining a high vehicle test rate. During 1993 and 1994, the Mexico government ran a parallel comparison study of 6-lane centralized macro centers and individual test stations located in repair or gasoline fueling facilities. At the end of the 2-year trial period, the government concluded that the macro center program was more accurate and had less incidents of cheating. The macro centers also operated at lower cost and provided much better statistics for future decisions. As a result, Mexico City plans to close all individual test stations and replace them with 45 additional SuperFlow-equipped macro centers. The SuperFlow test system for Mexico City uses optical emissions benches calibrated at 4 points for greater accuracy. An improved high-capacity sample handling system is designed to maintain accuracy at the high throughput rate. Chassis dynamometers are used to apply a load at constant speed. When it was completed in 1992, the SuperFlow Mexico City Macro Center testing program was the most advanced vehicle in-field testing program in the world. In January 1995, the state of Colorado opened their IM-240-based emissions testing center program in Denver. A 10-year Colorado Department of Health study determined the majority of all air pollution was a result of vehicle exhaust emissions. Colorado tested a number of different emissions measurement systems and finally concluded that the IM-240 standard would produce the best results. SuperFlow IM-240 dynamometers were selected for the test lanes. Each dynamometer utilizes mechanical inertia flywheels with an active electric motor to simulate the vehicle load and compensate for the parasitic and tire losses. SuperFlow developed all-new computerization using multiple microprocessors to provide precision control of the entire dynamometer test system. Automated vehicle restraints are used to retain the vehicle during the entire test. Each dynamometer runs a 4-minute test which simulates city and highway driving conditions. Exhaust gases are collected for the entire test cycle, with measurements made each second to determine the pollutants. Fast pass and fast fail algorithms were developed to shorten the test time to less than 4 minutes for many of the vehicles. SuperFlow's innovative four-wheel drive design eliminated problems with misaligned axles and the tendency of vehicles to surge from the front rolls to the rear rolls. SuperFlow also pioneered the use of 12.6-inch diameter rolls, about 32 centimeters, for vehicle emissions testing. Other test systems use 8.6-inch or 20-inch diameter rolls. The 8.6-inch rolls caused concern about the possibility of tire damage, particularly on underinflated tires. The 20-inch rolls created problems with the automated vehicle restraints and lift systems, which lead to consumer complaints about possible vehicle damage. SuperFlow's 12.6-inch diameter rolls eliminated both of those problems. For the Colorado emission systems, the SuperFlow dynamometers utilized many advanced algorithms for control and quality verification and far exceed the Environmental Protection Agency, or EPA, requirements. Colorado's test program is one of the most successful IM-240-based programs in operation in the United States. The state of Wisconsin began its centralized emissions test program a number of years ago, but Wisconsin decided to upgrade to the IM-240 standards. SuperFlow was selected to supply the emissions test dynamometers. For the Wisconsin program, SuperFlow developed a new version of the emissions test dynamometer. It utilizes electric inertia simulation through a vector flux control motor drive system. Integrating the motor control system, the dynamometer controls, and the safeties into a single electronic system has improved the accuracy and performance considerably. The Wisconsin IM240 dynamometers meet all EPA certification grade dynamometer standards for accuracy. SuperFlow has developed an enhanced safety restraint system for the Wisconsin emissions program, which stops automatically and backs up if it encounters any resistance from a tire or a foot in the roll area. In the event of complete power failure, the restraints may be easily disengaged by manually pulling them back from the tire. In Wisconsin, the dynamometers were designed to handle vehicles with gross weights up to 25,000 pounds. Inertia simulation is provided for vehicles up to 5,500 pounds. Vehicle emissions pollution is a major problem in all high-population areas around the world. Most major cities with populations over 1 million will have to install an emissions control program to maintain adequate air quality for their citizens. For any emissions air pollution program to succeed, the vehicles must be maintained. Manufacturers must design emission systems which will function for the life of the vehicle. The emissions testing programs force vehicle manufacturers and the vehicle owners to control the pollutants in order to meet beneficial air quality goals. When there are no in-field testing programs, vehicle manufacturers become more lax and the vehicle owners never get around to necessary repairs. Of all the testing systems, the centralized test program is the least expensive and most accurate. Centralized testing also reduces fraud and provides the best test statistics for making future policy decisions. Emissions testing has become an unavoidable requirement for the continued use of fossil fuel-powered vehicles in cities around the world. The winds of change are blowing, and SuperFlow is at the forefront.